Hi Hires, so still on metabolism and survival, we're now looking at how you could possibly survive nasty adverse conditions. So right back in first or second year we looked at tolerance curves, and I've mentioned them a few times. So here's your tolerance curve. So the percentage survival up the side, and the factor, whatever factor we're looking at, could be temperature, could be oxygen level, could be anything. Okay, so we have a kind of optimal tolerance, best conditions, generally most of them survive, it's all good. And then we have moderate tolerance, where some of them survive, they're doing okay. And then we have really minimal tolerance, they're only just clinging on there, and then we have just not making it. So how could you survive past normal tolerance? Okay, so how do you survive extremes? Several ways that they do that. So here's your first. You can enter a dormant state. And by a dormant state, what we're talking about is dropping their metabolic demand. So you lower what you're doing. You basically shut down. And because you're doing that, you don't actually require the same level of energy input, and so you can survive where you otherwise couldn't. It is a way of just avoiding what's going on. It waits out the kind of nasty conditions, and that might be something as clear-cut as it's the winter and I can't survive in that cold, or it could be a drought, or it could be something else which has just happened that you were not expecting. This is obviously a picture of a dormant volcano. So how do you actually trigger that dormancy? And so there are two ways that we can actually look at this. The first one is predictive. So by predictive, it's an expectation that something's going to change. So that's going to be a seasonal, like, as I said, winter. You know winter is coming. You've watched all the programs. But what you're really looking at here is probably going to be a trigger, like a day length change. You know that this is actually part of it and it will produce a response. The other option is consequential. I'm afraid that's the word. Okay. Consequential means as a consequence of. So what happens is a trigger that could happen at any point during the year, and that would actually make you trigger dormancy. So consequential is a slightly different one from predictive. You need to know several forms of dormancy. So first one is hibernation. Now this is, some animals use this. It is a long-term dormancy, it's over several months, and there is a massive drop in metabolic rate. Body temperature gets close to the ambient, so the external temperature, and everything is lowered in terms of the metabolic demand. And so mammals in particular go into dormancy, so learn a couple, like your little dormouse and your bears. Second form you need to know, and I am assuming a totally new word, this is aestivation. So aestivation is a response to high temperature or drought. And what we're looking at here is, again, drastically reduced metabolism. This is going to be a consequential one. And some nice examples would be things like snails. Snails can basically create a kind of thick mucus that plugs up the base of the shells. That still allows diffusion of gases in and out, but because their metabolism is so drastically reduced, it means that they don't actually need to do much at all. Earthworms will basically coil round and round, produce a little pocket of moist air round about a coiled body, and reduce their need at that point. And you have things like frogs and lizards and stuff like that can do similar things. Our next key term is torpor. Now, again, this is a drastically reduced metabolic rate. And if you are something with a super high metabolic demand, then it kind of makes sense that at times when you don't have a lot to do, like if you're not feeding, then you could reduce your metabolic rate, and that would mean that there's less cost. Okay, so animals that are active during the day, some are during the night, so you could see times when you would have a kind of flip back and forward. Bats are a very good example of this. When they're in torpor and you take, say, an infrared imaging of them, they will be pretty close to the ambient temperature. And then as they go into their active cycle, it will completely change because they have a super high metabolic rate, but when they need it. So this is all to do with cost benefit. Okay, big environmental questions. We know that climate change is affecting all sorts of things, but it absolutely could have an effect on this. If predictive states are triggered by environmental conditions as well, what happens if you trigger hibernation early? What about if it's not early enough? You consider what might happen to the organisms that we're looking at here. They might just not survive it. If we look at consequential states, a lot of them are obviously triggered by specific external environment things. What happens with a consequential state is it takes out active members out of the community. And that means that if you have a fragile ecosystem, this could totally mess it up. These are all just points that you need to think about. And that's that one.